Charlie asked a real good question a few weeks ago, and that was, how do we know if there are electrons if we can't see them? Well, I gave an answer to his mother, which was along the lines of, we know the properties of electrons and the properties in general of the particles in an atom, and we can explain a lot of things just using these relatively few number of things that we know about electrons and protons. Now, I forgot to mention that physicists use something called a cloud chamber, and what that will do is that's how they detect very, very small particles, because they'll leave trails in a cloud, similar to if you look up in the sky and a jet plane has already crossed, you can see where the jet plane has been because it will leave a trail of vapor. So you can look up and say, oh, that must have been a jet plane that had flown by. Well, they can shoot electrons through this kind of detecting device, and they can see the disturbance that it makes when it goes across. But what I'm going to do here is I'm going to use the properties of protons and electrons in various atoms. Electrons have negative charges and protons have positive charges. And kind of like magnets, negatively charged particles, like electrons, repel each other. Positive charged particles, like protons, repel each other. But negative particles are attracted to positive particles, and positive particles are attracted to negative particles. So I'm going to use that fact, and I'm going to use the fact that this can right here is made out of aluminum. Now, aluminum is a type of metal which is called a conductor. And what that means is that the electrons in the atoms of this metal move pretty easily amongst the various atoms of that metal. Now, this is a wooden pencil, and the electrons in the atoms of the wooden pencil don't move. They're very tightly bound to their atoms, and that's why wood would be considered not a conductor, but an insulator. So the next thing I'm going to do is I'm going to take this rubber balloon. Rubber is an interesting material as well because it loves to collect electrons. And what I'm going to do is I'm going to just rub it on my shirt, and it will pick up spare electrons from my shirt. My shirt's made out of cotton. If you have wool, it'll be even better. So I'm just going to give it a good rub. And we'll see if we can collect enough electrons to make this experiment work. Now, you remember I said that if we carry the model of the atom in our heads and what positively charged particles and negatively charged particles, how they interact with each other, I think I can predict what's going to happen when I bring this balloon close to this can. And what's going to happen is there'll be an excess of electrons on one side of the balloon, and it's going to push the electrons closest to the balloon to the other side. Well, what happens then? Well, then what we have on that side are protons, which are positively charged, and they're going to be attracted to the electrons in the balloon. So hopefully we're going to see the thing move. Let's see what happens. Oh, I love it when I'm right. It actually works pretty easily. Now, to test things thoroughly, I say nothing's going to happen when I move this pencil. Let me get a good charge going up. And as you can see, this pencil does not budge because the electrons are so tightly bound to their atoms, they just don't move. So kind of my conclusion is, it's more important that we know how electrons and protons and all these other particles that we can't see behave rather than actually see them, although it would be kind of cool to see them. But if we know how they behave, then we can predict all kinds of things from a very few facts. Like I can tell you why lightning occurs during a thunderstorm, because there's an excess of negatively charged particles and it gets attracted to the ground. Or I could tell you how light works, because I flip a switch and then the electrons go running toward a positively charged terminal and make the light shine, and on and on and on. Whereas if I had some theory where I said, well, uh, aluminum is attracted to the color yellow, then I can see the can, I can see the yellow balloon, but then when I put a red balloon down there, you've got to explain why it's attracted to the red balloon and why this is not attracted to the yellow. Things get real complicated real quickly. And science usually tries to make things as simple as possible. Hope you enjoyed that little experiment. Hope you can try it for yourself.